Imagine a place on Earth where sunlight never reaches, a realm of crushing pressure, extreme cold, and an abundance of life forms that defy imagination. This is the deep sea, and it remains by far the largest uncharted territory on our planet. Despite covering over 7% of Earth's surface, more than 80% of our oceans remain unexplored. This means we know less about the deepest parts of our own planet than we do about the surface of Mars or the Moon. Why is this the case? The challenges of deep-sea exploration are immense. The sheer scale of the ocean depths is staggering. The average depth of the ocean is about 3.7 kilometers, or 2.3 miles. But some trenches plunge far deeper. The deepest point on Earth, the Challenger, deep in the Mariana Trench, descends nearly 11 kilometers, or almost 7 miles, below the surface. To put that into perspective, if Mount Everest were placed in the Challenger Deep, its peak would still be more than a mile underwater. To withstand the incredible pressures of these depths, where every square inch of surface can experience pressure equivalent to dozens of jumbo jets, specialized technology is essential. Early, human-occupied submersibles, like the bathysphere and the Trieste, paved the way, demonstrating that human presence was possible in these extreme environments. However, modern exploration heavily relies on remotely operated vehicles, or ROVs, and autonomous underwater vehicles, AUVs. These robotic explorers can delve into depths beyond human endurance, equipped with high-definition cameras, manipulators for collecting samples, and sophisticated sensors to gather invaluable data. They are our eyes and hands in a world that would otherwise remain hidden. One of the most astonishing deep-sea discoveries came in 1977 with the finding of hydrothermal vents along the Galapagos Rift. These geological formations are essentially cracks in the Earth's crust, where superheated, mineral-rich water erupts from the seafloor. What was truly revolutionary about this discovery was the vibrant ecosystems that thrived around these vents, completely independent of sunlight. Instead of photosynthesis, the foundation of these ecosystems is chemosynthesis, a process where microorganisms convert chemicals from the vent fluids into energy. This changed our understanding of where and how life could exist, not just on Earth, but potentially on other planets and moons in our solar system. The creatures of the deep sea are a testament to evolution's ingenuity, adapting to perpetual darkness, extreme pressure, and scarce food. Many deep-sea animals exhibit bioluminescence, the ability to produce their own light. They use this for hunting, attracting mates, and even defense, creating dazzling light shows in the blackness. Take the anglerfish, for example, famous for its glowing lure to attract unsuspecting prey, or the eerie goblin shark with its distinctive elongated snout and protruding jaws. Then there's the extraordinary giant squid and colossal squid, creatures of legend that truly exist, inhabiting the crushing depths and remaining largely elusive to human observation. And we are constantly discovering new species. Thousands of new species are identified each year, from bizarre jellyfish to previously unknown types of fish, highlighting just how much more there is to learn. The deepest parts of the ocean, the oceanic trenches, are among the least explored. These are not just deep holes, but vast, elongated depressions formed by tectonic plate subduction. The Challenger Deep, mentioned earlier, has only been visited by a handful of human-occupied submersibles and a few robotic probes. Each descent is a monumental engineering feat. What scientists are finding in these trenches challenges previous assumptions about life at such extremes. Microorganisms thrive, and even larger creatures like amphipods have adapted to the immense pressure. These trench ecosystems are essentially isolated islands of life, with unique species found nowhere else on Earth. the deep sea is not just about strange creatures. It's also a realm of vast geological features, untapped mineral resources, and potentially crucial clues to Earth's past and future. Vast underwater mountain ranges, abyssal plains, and enormous canyons remain largely unmapped and unstudied. Each of these features could harbor unique ecosystems and geological processes. Scientists are also exploring the potential of deep-sea mining for valuable minerals like manganese nodules, cobalt, and rare earth elements. However, this also raises significant environmental concerns about disturbing these fragile ecosystems. Furthermore, the deep ocean plays a critical role in regulating Earth's climate and biogeochemical cycles. Understanding these processes is vital for predicting future climate change impacts. Our journey into the deep sea has only just begun. Each discovery opens up new questions, revealing the extraordinary resilience of life and the dynamic nature of our planet. The continued exploration of these uncharted territories is crucial, not just for scientific curiosity, but for understanding the health of our planet, discovering potential new medicines, and managing valuable resources responsibly. The deep sea is Earth's last great frontier, a silent world brimming with secrets waiting to be uncovered. What wonders will we discover next? Only time and continued exploration will tell.